Oh, okay. Well, I have to turn your volume up substantially.
Okay.
Hold on.
Do what you need to do.
Say something.
You sound like you're at the bottom of a well.
But so do you. I feel like this is
What's
not.
up with that?
I don't know.
I don't have my big Dorkarama headset with me right
No,
now. That could be it. That could be it.
that
Is
could
it
be
time
it.
for me to buy a new headset, maybe?
Well, I mean,
Like,
what?
or a headphone?
Yeah, probably those. I mean, you don't just like take your headset with you where you go.
So, this is my electronics bag, which is different than my makeup bag. And unfortunately, those giant headphones that are the size of a small coyote are too big to fit in my electronics.
Okay. Well, that's a really small bag.
It's a maybe I should get a bigger bag. Maybe that's just been the problem in my life is my electronics bags are too small.
Yeah. So I want to make sure chat. Everybody said some people were saying that they could hear you just fine. I just want to make sure that's true. Say stuff again. Just talk again.
I'll just talk about stuff. Yeah, there's a big event tonight. The launch party is happening tonight. We've had over 200 RSVPs. Super pumped. Giving a talk, doing Q&A, book signing. There is cheese involved. I got to be in charge of the catering menu, and I picked all the cheese.
All cheese? Is it just literally just a whole thing of cheese? Like no crackers, nothing else? I could see you
well,
doing this.
there's the speakers table, and I asked that I wanted coated every square inch with cheese cube, like as if the table were made out of cheese. And then as I talk, I will eat the cheese cubes one by one, and I'm gonna time it precisely. Every 5 seconds, I eat a cheese cube, and then I know when the time is up for my talk, it's time to do Q&A because I've finished all the manchego. And then when I move on to the white cheddar, that's when I know it's time for.
Yeah, and I think when you said that name of that cheese, you just sneezed. Say it again.
Manchego?
Okay, I've never heard of that. I'm not that fancy. I'm gonna have to learn
It's a
these
Spanish
things.
cheese. It's a Spanish cheese.
Oh, that would be
All the
why.
Manchego fans in the house. Look at that. See
I
the
know
chat
everybody
knows.
is now
Chat
showing
loves
me up.
it.
Doesn't have much lactose.
It's an age. It's an aged cheese. So yeah, you're right. There's not a lot of lactose.
Man cheddar.
Different substance, different consistency, different manchego. That's Spanish for manchego, though.
It's melty too, so that's a plus. Okay, I'm sold on that. I'm sold on that. I'm
You should get
absolutely.
yourself. You should come to the book launch party. We
But you're
have displays of manchego.
if I would have learned about this, well, traveling right now, people are traveling.
A little bit
The
challenging.
lines, the lines would be really long right now. Yeah.
Oh, because of this whole holiday Thanksgiving.
Yeah, this whole Turkey Day thing going on. So
There's direct flights from Columbus to Denver. There's only like direct flights from Columbus to like 5 cities, and one of them is Denver.
I'm not worried about the plane. I don't like the lines.
There's the line.
We
I
need.
wish Disillusion suggests that I'm starting up a cheese business. I feel like if I were to get into the business of cheese, my love for it would die.
Is that how you felt about space when you're like, well?
That's exactly how I feel right now about this stupid book.
I don't know if you guys saw the tweet that I retweeted, which was great. Your pitch was perfect. Blah blah blah.
I'm like so tired
Just buy
of
the book
because I keep getting like my publicist and everyone's like, oh, come up with witty things, say funny things, let people know your personality. I'm like, fine, I'm gonna show people my real personality.
That's the way you do it.
Shut up and buy my book.
Yeah. Blah blah blah. Just buy my book.
I don't
already.
even care if you like it. Just buy it.
Yeah.
I don't
exactly.
even care if you read it. Just get a copy because I got bills to pay, folks.
Right. And so let's see. It's a YouTube guy. I see him all the time. And yes, this is Dr. Paul. He's the YouTube guy.
Said no one ever. I mean, that is the first time in my life
That's a
I've been
big title.
referred to as, oh, Paul Sutter, the guy from YouTube.
Yeah. I wouldn't ever refer to him that way. That's giving him a lot of credit. That's a lot of credit. But he does have a lot of stuff on YouTube. He has Ask a Spaceman podcast, which he puts stuff up there. We just watched something about Wolf Rayet stars that you...
Wolf Rayet.
Rayet. Rayet. I said it right.
Français, s'il vous plaît.
I know, but see, people say... I was watching some guy actually say it completely wrong. I think he said Rayer.
Rare.
Yeah.
Wolf Rare stars.
I was like, Merca.
Merca. You gotta catch them down in the holler. And man, those scurry little buggers, they'll run right away. But you give them 2 shots, bang, bang, you'll get them. You'll get them. You skin them up, and man, they make the best sausage. You would not believe. You smoke them dry. 2 weeks.
That's some Cape Kona astronomy, guys. That's right, bub. But yeah, no, and we were watching something about that. Someone said Thorin Jitkov. No, we're not talking about TZOs, not TZOs. Those are like stars embedded in other stars. Those are theoretical right now, but I think
those are like you like stars, or we put a star inside of your star.
Yeah, those are like the Russian nesting dolls of stars.
Yeah.
Yeah, a star inside of a star.
How many levels can you go?
Oh.
Do you put a star inside of a star inside of a star?
I don't. I think we're struggling with just a twofer right now. Just having.
We're the double ender.
Mm-hmm. But don't worry, you got Kip Thorne all over that, and also I think it's Anna Zhikov.
Yeah, Kip Thorne and who?
I know it sounds. I know how to pronounce that one.
Poor collaborator. It's like the Einstein-Rosen bridge. The only reason people know who Rosen is because he wrote a paper with
Einstein.
Talk about writing coattails.
I know. Well, that's how I feel with you every day.
I don't believe that for a second. You're famous in your own right. Right?
No, I'm actually not at all.
No, people come up like, oh, that's Sky. You talk to Skylius from Twitch?
Who says that? That never happens. You're being so nice. I need to write a book. But so someone
that is the thing. People are doing it. It's writing the books. Fraser has a book out. I have a book out. Mike Wall has a book out. Neil deGrasse Tyson has a book out.
Mm-hmm. Yeah, Skylius, the girl from Twitch.
You're next. What's your title? What's your hook?
Well, that's the thing. Everything I'm going to say is going to be denied by publishers. What if I said big blue balls? What if I just wanted to talk about stars? I feel it's relevant.
Okay.
I mean, the publisher would be like, America's not going to like that.
I had no idea how this world worked before I actually wrote a book. And I looked up online, how do you publish a book? And there was the self-publish route, and then there was the traditional publisher route. Now I picked option B, and step 1 is to get an agent, and your agent is the one that does the hard work of selling your book to a publisher. And really, when it comes to nonfiction, here's the big secret, everyone. The publishers kind of care about your content, and if the book is any good, what they care about is your audience size.
Oh, well, I think I would have like a solid maybe 150 book sales, but I think that's about all I would get.
Hey, you know what?
Is that pretty good?
That might just be enough.
To make it worth it?
To make it worth No, but that's what they care about, your platform. And so you write a pitch, like a proposal, that's part the book, like you do an outline. You don't even have to write the whole thing in the nonfiction world. You just write a chapter and like list your other chapters. And then you spend half the proposal describing how you're going to sell it.
Yeah. I'm doing great on a gaming platform. It's amazing. This isn't even supposed to happen. It's not even popular.
No, you wouldn't believe it. So last week I was in LA at this author retreat. And we had representatives from media companies, from producers, from some companies that do all sorts of things. And they were talking about Twitch. They were talking about the power of Twitch.
And did you say I know somebody from Twitch? Hey, there's a Skylius girl on Twitch.
I know you won't believe me, but I did drop your name a couple times.
And they were like, really? Okay, cool. So about Twitch. I know the girl from Twitch.
I know the girl from Twitch. You know that one girl?
That one
woman.
girl.
She's you know that. Yeah. Do we call women girls?
Ladies, whatever. I don't care.
Ladies. I know the lady from Twitch.
Yes. Yes, you
I
do.
know.
But I wanted you to break the news of what we're doing next Wednesday because it's going to be amazing.
Oh, you saved this?
Yeah,
For me? This is so fun.
I know.
What exactly are we doing?
We already talked about it via email.
Oh, yeah,
Okay.
we emailed about this.
Yes.
We discussed this.
Mm-hmm.
So Wednesday, and it's at 9 p.m. Eastern,
Yep.
7 p.m. Mountain.
Mm-hmm.
On the mountain, it's 7 p.m.
Mm-hmm.
And I'm going to read from my book. I think I'm going to be sitting in front of my Christmas tree and my fire.
Mm-hmm.
Super cozy.
Mm-hmm.
I'm going to wear a sweater. I don't have an ugly Christmas sweater, so
I do.
I think I'm going to go upscale.
I do.
I'm going to go like a cardigan or something.
That's fine. Mr. Rogers, you're good.
Very Mr. Rogers. I'll start off by switching into my loafers. Telling you about what it means to be a good
But
person.
the pipe, you have to have the pipe. You have the pipe, right?
I'll look for a pipe. I'll have a bubble pipe. The Muppet
bubble
Babies
pipe.
bubble pipe.
So someone said a pipe that blows bubbles.
Yes.
Yes, that would be so great.
Exactly.
And I'm going to be doing the reactionary stuff.
Okay, yeah. So do you want to read from the book at all? Because I know my publisher is sending you a copy.
Oh, I already got the
and
copy.
I sent you a copy. Have you got the copy yet?
I haven't got it in the mail yet, but I got the publisher's copy. And I was looking through that. No, but I can do. So we're going to agree on, in the next day or two, I will read that chapter, and trust me, when I hear the end of a sentence, I will have a reaction. And I have an ugly Christmas sweater. I already bought it. I already did this. That was like a part of my weekend, that was on the agenda. Go get an ugly Christmas sweater. So
it's on the list. Yeah.
It's done. It's purchased. So this will be internet gold. This is going to be amazing. So that's next Wednesday, guys. He's going to read from his book.
It's going to be tons of fun. Actually, I'll read from the book. You'll react. We'll tell some lame jokes. It'll be a Christmas special.
Mm-hmm. Have some hot toddies, just kind of sit back and just have these pretentious laughs. Like,
how witty yet insightful Skyly is.
Wow. Yeah.
I'm going to have to tell my nanny that joke.
My landscaper. I thought ugly holidays.
I sent Jesus home for the winter, but when he returns in the spring, he's going to crack up.
It's going to be so great. So we're doing this. And, it's something that actually, Dr. Paul, you wanted to do before. And I think now you having a book.
I pitched the idea to you like
forever ago,
months ago. And you're like, nah, pass.
Yeah. But,
and I didn't I pitched it to you and you're like, I guess you're big enough.
I was like, you did write a book. I guess since you wrote a book, fine. But yeah, so that will be, definitely won't be able to, well, I also will upload it to YouTube as well. And I do tag him in that.
We'll put it out there. We'll archive it.
Yep. It'll be completely archived. By Dr. Paul's book here. Yeah. So today, guys, is the release of his book.
It's out in bookstores nationwide. If you pre-ordered it, it will be arriving today. I got a case of 150 last week that I will be signing and selling at all the events I'm doing around town. You can also buy an autographed copy off my website, and I'll ship it to you myself. And also my Patreon supporters are getting free books. So I'll be mailing this out.
And you guys, he has a link to the Patreon if you do the Paul command. It's all there. And his Patreon, this is what we do. I have a way for people to subscribe and stuff, which is amazing, but this is how we're able to do these kinds of things as science communicators. But he's an actual scientist and a science communicator. So he has an extra badge on me with that. I've got a little medal. Yeah.
It's on my sash.
I was going to say it's more like a Boy Scout badge, but that's fine. We'll just...
You know,
Okay.
Boy Scouts, Order of the Arrow. It's a sash. It's a sash. Like,
I'm gonna need a
I
digital.
was an Eagle Scout.
I'm an Eagle Scout. I'm gonna need a digital signature with the certificate on my copy. um.
Sure. How do you do a digital signature? Good question.
Do you even have space for 150 books with all those boxes already in your office, Dr. Paul?
Oh, harsh. Harsh. The knife cuts deep.
You know, no one
The
notices.
books are in the trunk of my car.
So that would be a yes.
I do not have enough room in my office.
Now we know he doesn't drive a Geo Metro. So we're gonna get in with a little
gotta
bit.
get rid of those telescopes.
I know.
But
I know.
what we need, can someone in Columbus win one of your raffles so that I can just hand them the telescope instead of shipping to, I've shipped to like every corner of the world, every continent, and probably including Antarctica.
I know. I would just say send him to me and I'll ship him out. But I don't know. People might feel it's a little bit more special coming from you.
Away. I know. How about at my events? I'll just give away telescopes at my event.
You should.
Yeah, you should. Like, hey, buy 5 books and I'll give you a stupid telescope. It's not stupid.
It's not stupid. Dodgy was really excited once he had clear skies, which is really hard to have. I don't know whether he was more excited for the clear skies in the UK or for having the telescope.
Probably both.
Probably both. Half a chat is like, what is a Geo Metro?
It's like, whoa. Yikes.
3-cylinder vehicle.
Tiny car.
Very small. Buy my book, blah, blah, blah. Here's your stupid scope. It's great. It's great. No, he's great with this. He's great. So I did want to talk to you a little bit about, so we're talking about Wolf-Rayet stars today.
Wolf-Rayet.
Rayet.
I'm going to correct you. So I cracked up, when I was filming with the latest round with the Science Channel, we talked about these stars. And of course, it's a British production company. We've talked about how they encouraged me to be more energetic. But they were saying Wolf-Rayet star. And I said, oh, it's French. It was discovered by 2 French astronomers. So it's Wolf-Rayet. And they had me repeat it like a dozen times so that this is what they said, so that Mike Rowe would be able to narrate it correctly.
Oh, wait, they actually have an episode about those on how the universe works. They talk about them?
Coming up in the next season. I don't know if it'll make the cut, but there were a bunch of questions about Wolf-Rayet stars. Apparently I was the only contributor to pronounce it correctly.
Well, I'm not saying Rayet. I'm saying Rayet.
Rayet stars.
Rayet.
Wolf. It's not hard. Just Wolf.
Rayet.
Rayet.
Are you judging me on my ability to like hawk up something? Rayet.
I am very particular when it comes to French for no reason. I lived in Paris for 3 years. That's why. And so I acquired the snobbiness about the French language.
Okay. Well, am I okay to say
it was infused in my blood?
So saying Rayet would be bad still? You would cringe at that, even though like I got it pretty close than most?
I would say as long as you don't hit that T.
I never hit the T. The T is silent.
If you don't hit the T, you're all right.
Yeah, I'm good.
You can do whatever you want.
I've never hit the T.
Don't hit the T. Just like my name. It's Sutter. Don't hit those T's.
Real Sutter. Got it.
Paul,
I'm going to write
Sutter.
that one down. Paul Matt Sutter. Got it. Okay. Well, I'm glad that he.
There you go, Abraham. That's exactly it.
Yeah, my last name is French too, but I can't say it on here. With the silent T. It's Paul with the silent T. That's right. So tell me what do you know? Because I know that again, like, you know, I've not been able to find any kind of documentary sources on these stars because they're rare. They're super rare.
They're super rare. I did do a video on them.
I know. I watched that one. How they work.
So the reason I know about them is that they were discovered at the Paris Observatory. And I worked at the Paris Observatory for 3 years, right next to the Paris Observatory. And I saw the building. I worked right next to the building that housed the telescope that Wolf and Rayet used to discover Wolf-Rayet stars.
Mm-hmm.
So it was a little bit of Parisian lore, if you will. And the reason we don't know a lot about them is, like you said, they're rare. We only know of like a couple dozen examples. And if there's only a couple dozen things, it's hard for us to do science because the data aren't very good. We don't have good statistics. We can't build models. We can't test hypotheses. So we just have these things that behave in a certain way, and they're very, very rare. We suspect they're rare because they don't last long. We don't think Wolf-Rayet stars last very long. And so if something doesn't last long in the universe, then in the small slice of time where we can observe what's going on, we're going to have a biased picture. We're going to see more easily the stuff that lasts a long time because we'll have a lot of examples of them. But if they're very rare, it'll be harder for us to see.
Mm-hmm. Yeah, like pretty hard because these guys only live, thousands to, a couple million years. I mean, they don't live long.
Exactly. We believe that Wolf-Rayet stars are the very end stages of a massive star's life before it goes boom. So this is the pregame. This is the pre-party.
Okay.
Before the big blowout.
So would you be comfortable saying that a star like Betelgeuse in the Orion, that it had, started at had been at some point one of these WR stars, which is what we classify them, one of these Rayet stars?
Right.
Would you say that at one point we maybe would have called it that?
Maybe not. I don't think Betelgeuse has gone through this kind of phase, and it's not exactly clear. This is another layer of the mystery, that it only appears that some stars enter a Wolf-Rayet phase, not all of them. And even amongst the most massive stars, it appears that not all stars enter this phase before going supernova. So it appears to be you need a very special set of circumstances to trigger this phase before a supernova. Maybe it's mass, maybe only the biggest stars. Like you need 20 or 30 times more massive than our sun in order to enter one of these phases, or maybe not. Maybe you need a special mix of chemicals. Maybe you need a certain kind of environment around the star to trigger it. We just don't know.
Yeah, and there's actually a lot of really good questions coming in already. Supernovas don't last long, yet we see them. No. The remnant of a supernova explosion can last quite some time.
Right.
And
what helps with supernova is they're super bright.
Right. So their luminosity.
We're not limited just to our own galaxy. When supernova go off in other galaxies, we can capture that. So we can cast a very, very wide net, even though they're rare. Wolf-Rayet stars are not nearly as bright as a supernova, so we're pretty much limited to our own galaxy. So we have a very, very limited net to see them.
Yeah, and we've been able to detect them, I think, in the Magellanic Clouds as well. But outside of that,
That's
right. They're still, guys, for stars. These are still very luminous for stars.
For stars.
And someone said, why do we think they don't last long? Can we not observe them? So he was just describing that basically, so humans have only been around for, 250,000 years, ish. 4,000
or 5,000 years tops.
Right. At tops. Right. And we've only been able to observe these things and know what's kind of going on within, we've been doing observations actually for thousands. Right. But like actual observations that are recognized. Yeah, exactly what you said there. You can state it again because I might have talked over you.
We discovered them 150 years ago.
Yeah. So so that's, keeping up with something like this. And the way that we, from what I understand, and this is also what I wanted to ask you, is one of the ways that we detect these is because of the certain elements contained in them when we do spectroscopy. There's different kinds, right? There's different kinds of these stars where you might see more nitrogen in the emission lines. You might see more carbon or oxygen. But these are population 1 stars. These are, or at least from what we're seeing. Again, we have a really small pool of these. And they seem to be, from what you know of them, and I know, again, this is like a certain like subset that we, I was a little scared in talking about them because we really don't know too much. But
there's not much to say.
There isn't much to say. They're like super massive. They're big. They're impressive. They're very hot.
And they pulse.
Right. They do that. But like with the, I guess what I was going to ask is, other than just like spectroscopy and sheer mass, like we know of one that might be 250 times the mass of our own star. Are these mostly in these binary companions, or are they usually in some kind of companion system where there's multiple other stars, maybe similar to another, like a twinsy?
Maybe like massive stars. So with Wolf-Rayet stars, we know they're massive. Massive stars tend to be born in clumps. They tend not to be born isolated, because if you have enough material to make a giant star, you usually have enough material to make a bunch of stars all at once. So we tend to see massive stars in binary systems. Now, does this mean, and so this means that Wolf-Rayet stars will tend to be in binary systems just because massive stars already tend to be in binary systems.
Yeah, and that makes sense. So there's, someone said if a WR star, which you guys, just so you know, that's the abbreviation of saying Wolf-Rayet, it produces so much. I'm not saying the T.
I was shaking my head at something else. It was totally right. Unrelated and 100% coincidental
totally buying that.
To your pronunciation of Wolf-Rayet.
Great. Okay, so I'm just going to say WR stars because now I'm getting like a complex about this.
Stars.
Great.
Yeah, I like this. So this is born
stars.
of decades of bullying in grade school and high school that I lash out and try to bring other people down so that I can feel better about myself.
I do it all the time too. It's so weird. So weird. But no, so someone says if a WR star, which this is actually how the question was asked, produces so much radiation pressure, how does the fusion still manage to keep going?
Oh yeah, so from what little we've understand, we've done some modeling, we've done some simulation to figure out what the heck is going on inside of a WR star, a wide receiver star, according to have 73, which
that's absolutely a wide receiver star. Let's go.
I like it. Is that this thing is massive. It's really hard for us to comprehend such a big star. A giant star like that is not one cohesive ball of plasma. There are different layers, and the layers don't always connect to each other and don't always talk to the other layers. So inside of our sun has layers. There's a core, and it's surrounded by a convective layer where gas or the plasma of the sun is churning up and down, up and down. Sorry, I totally messed that up. There's the core surrounded by a radiative zone, which is dominated by radiation, and then the churning convective zone,
right.
And then the surface and the atmosphere. With these, and they all talk to each other. So they're all transporting heat from the core to the edge just in different ways. But when you get up to massive stars like this, it's like going from an urban core of a city to the suburb. The suburbs are associated with the city and can send stuff back and forth to the city, but can also live their own life. You don't always have to go into the city every time. So in these massive stars, you have the core, which is burning elements, hydrogen or helium. You might have convective layers and radiative layers, and then you have the suburbs. You have this thick outer shell of atmosphere that isn't always connected to the interior layers. And so what we're seeing is the suburban layer, this outermost layer, pulse and back and forth, while the rest of the star just keeps doing its thing, if that makes any sense at all.
Mm-hmm. Yeah, it does. And someone actually said in here, these are bringing up really good questions. Nope. This was going to be my question. Nope. Wait, do the deep layers come out in jets? And could they move the star? So that's going into the next area that I haven't wanted to go in just yet. I'm talking about GRBs and stuff.
Gerbies.
Yeah. Because I kind of wanted to wait for that. But these are obviously very weird. I mean, they're more massive. They can fuse down the periodic table more so than our star. These are those high mass stars. Yeah. And again, they live very short lives and have very explosive deaths. I believe the type of supernovae they produce, I don't think it's 1A. I think is it 1B, 1C?
These are going to be type 2ers.
Are they?
From core collapse.
Are we sure about
the type ones? The type ones are when you have a white dwarf that gets too much mass and triggers a critical chain reaction.
Right, but what if they have a companion that's not necessarily a white dwarf?
If the companion of a star is not a white dwarf, then you can get up where you can get transfers of material from the massive star to its less massive companion. That can trigger a supernova, but it's in a very, very different route. It's not that instant critical flash that you'll see with a white dwarf explode.
Yeah, because from what I'm reading here, it says type 1b supernovae lack hydrogen in their spectra. The more common type is the IC or the 1C, sorry. The 1C supernova. That's weird. Theory suggests that these are the progenitors for the type 1bc.
Oh, really?
Yeah. But again, this is all really disputed. See, these are like weird stars. Like, we don't understand these ones. Because I would agree with you, too. If it's a type 1, I mean, those are going to be substantially more rare than a type 2.
I'm digging through right now because I don't know.
Yeah, well, so the reason I'm actually talking about this is there was a press release that came out yesterday.
Oh, I bet there was.
Yeah, and it's talking about this, and I can actually link it to you in Discord real quick.
Yeah, link it.
Because it's really cool, and I wanted to share it with everybody. I was like, this is new news, guys. I just wish that they had like a TLDR for a lot of these things. I'm just going to say that right now.
It might be that certain kinds of supernova, especially type 1s, we basically don't know what causes them.
Yeah.
Or they're weird. They're weird. And this might be a candidate for them.
Yeah. And I sent you the article by Phil Plait just because it's kind of easy to look at it. And you'd be like, oh, okay, I can kind of see what's going on there. It's easier than the actual press release itself. So it's weird because they were able to observe this directly. And I'm an astronomy student sitting in the campus planetarium doing work right now. I love the simulation mapping programs. Yeah, this is called Space Engine. It's available for free for now. And there's also things like Stellarium. You might be familiar with Stellarium, but yeah, this is Space Engine. It looks like everybody was saying that before. But this is a little bit better than Stellarium, in my opinion. And they get these egg shapes, like this one that we're looking at now, because they're rotating so quickly. Am I wrong in that?
Nope, that's exactly right. Some stars rotate so quickly. It's just like Saturn. Saturn is spinning so quickly it bulges out at its equator. Some of these massive stars, in fact, I think we think most massive stars are bulgy around the middle.
Yeah, this is an egg. People are saying it looks like a Mentos. Um,
I would choose Mentos over egg. Yeah.
yeah, I would too. It kind of does look like a Mentos. Um,
So I'm reading the Phil Plate article, and it links a Wolf-Rayet star to potential gamma ray bursts.
mm-hmm. Yeah, this
Which,
was
if Wolf-Rayet stars are the most massive stars, then when the most massive stars go off, they're gonna generally, we think, might be the source of gamma ray.
right. So we can go ahead and just get into that real quick. Well, real quick. Let's go ahead and just touch on gamma ray bursts, Dr. Paul.
Gamma ray
So
bursts.
why do we
gamma ray,
think? Yeah. So why do we think? What are first? Do you want to tell people what gamma ray bursts are?
Yeah, gamma ray bursts. So gamma rays are the very highest energy kinds of radiation out there. And in order to make gamma rays, because they're very high energy things, you need a source of a lot of energy. You got to blow up something big to get enough energy to make gamma rays. And we see little flashes. We have gamma ray telescopes because we're good and we're astronomers. And we see these little bursts of gamma rays coming from all over the sky. And whatever is causing them must be incredibly powerful just to be able to manufacture enough gamma rays that we could see it, and very, very short-lived, because we just see them like, bloop, they're gone.
Right.
I think they're like a few seconds, like a maximum of like 10, 20 seconds, and then they're gone. So these are incredibly powerful events that don't last for very long. My favorite argument for the source of gamma ray bursts is Star Wars.
Mm-hmm.
You know, you blow up a Death Star, that's probably a gamma ray burst, right?
Mm-hmm. Sure.
You know, and we have the documentary footage that shows, you know, that was a few seconds of detonation.
Right. Okay, I'm buying it.
Right. And so, you know, lots of energy,
Mm-hmm.
you know, the force, all that good stuff. So another potential candidate is supernova. The most powerful supernova might be able to produce enough gamma rays in a short enough window of time in order to make this. But it can't just be any supernova. So if the supernova is perfect, if it explodes evenly in all directions, that's not enough to make a gamma ray burst, because you're taking all that energy from the supernova and spreading it out over all directions of that explosion. And then when we see from a distance a certain amount of gamma rays, you can figure out how much energy that event took. And there isn't enough energy.
Right.
If the detonation happens all over the surface simultaneously and spreads it out, it's too thin.
Right.
So we think it has to be directional.
Mm-hmm.
That something is causing the supernova to go off, not like a bomb, but more like a shotgun. And it's just blasting off. And then we happen to be unlucky enough to be in the path, and we get a focused beam, a burst of gamma rays.
If we're, you know, in the direction of one of the poles of the star, correct?
Exactly. So we think that beaming happens along the axis of rotation of that star. That's what sets everything in motion. That's what sets the beam. And then the beam can point in any direction in space. Every once in a while, it aims towards the Earth.
And how do you get a rotation of a star? How do you know where its poles are?
Well, we honestly don't know. Like we think the gamma ray bursts are caused by a fast rotating star that's beaming its explosion or its jet towards us.
Mm.
But we do see stars rotating. Our own sun rotates. We're pretty sure it'd have to be incredibly weird for a star to not rotate, simply because of the formation of stars. They start out as giant clouds, and as they collapse, any slight random rotation will get amplified, like a figure skater pulling their arms in, go faster and faster and faster. So all stars, I can say with confidence, spin to some level. And we think the most massive stars spin a lot because they form from a lot of material collapsing.
Yeah. And I will put that up, bud. And wait, astronomers finally spot the type of star that leads to type 1c supernova. Is that from recent stuff? Is this talking about this event today? Because I haven't read that one yet.
Oh, that's on Universe Today?
It might have been. Is that from today?
18 hours ago.
Ow. So like,
I see. Yeah, type 1c is a core collapse supernova, but it's been stripped of all its hydrogen, helium, and boron.
Right. Those are like going to be like different elements that are taken away. Yeah. They can lack both their hydrogen and helium, actually, from what I understand. I could be wrong. GRB roulette. Yeah. So, and again, like, so we, I was telling people our sun is actually tilted about 7 degrees. And someone's like, so how do we know that? Wouldn't we be going by our orbital plane?
Oh, yeah. We can actually detect this through the motion. Oh, early on, the first way we were able to detect this was through the motion of sunspots.
Oh.
So if you watch sunspots crawl around the surface of the sun, you realize that the sun is spinning, and B, it's inclined slightly relative to our orbital plane.
That's actually really cool. I didn't know that. So how do we know that there's nothing that has a shorter wavelength than gamma rays? Well, because...
Oh, good question. If it's more energetic, it's still just lumped in with gamma rays. So it's once you hit a certain minimum energy or wavelength threshold, then you're in gamma ray land, and everything past that is also called gamma.
Yeah.
Just like at the bottom end, once you get too low energy, you go into radio, and anything that's even lower energy is also still radio.
Right. And so that people, when they hear the word GRB, and if they remotely understand GERB, if they understand like kind of the amount of energy that's output, and if we're ever in that directional path, which from what I understand, again, those jets, if it is concentrated, if it is a directional thing, it would get pretty narrow. So still the chances of it hitting Earth, even with the increase, like it being narrow, would be pretty low. Mm-hmm. But, these are things that are cosmic killers. So a lot of fake news comes out with these things.
Fake news.
Mm-hmm. So are we going to die from a gamma ray burst? I'm supposed to ask that question.
They're rare. We don't fully understand them. They're very energetic. They're very exotic. So it's the same kind of story as Wolf-Rayet of we don't have a lot of examples. They're extreme physics, and we're still kind of feeling things out.
Hello, I'm an automated bot by Google to spy on you. Great. So someone said, so there are lower, so Bud said, so there are lower and higher limits with the energy, regarding light.
I should say there's strictly no limit. The electromagnetic spectrum can take on any wavelength it wants. I suppose, I don't know. I don't want to go down that road. Never mind. Let's just say it's a continuum, but we stop dividing things into boxes once we get up to gamma or down to radio wave.
Right. And so if a gamma ray did hit Earth and it was strong, what would we expect? Do you know what we should expect?
Well, gamma ray bursts, thankfully, there are no nearby threats of gamma rays. Any star that could eventually lead to a gamma ray burst is well and far away from us. We checked. That was like one of the first things we checked once we realized that gamma ray bursts were a thing.
Of course.
But we suspect, and this is highly, I don't want to say suspect, but it's very hypothetical. We're not sure about this. And I don't remember the timing. There is one particular extinction event that we think might be linked to a gamma ray burst. where a gamma ray burst, a nearby one, went off, and all these gamma rays, this high energy radiation hit our atmosphere and actually disassociated a bunch of ozone. It just slammed into the ozone and broke it apart, and it depleted our ozone layer, which our ozone layer is really good at protecting us from deadly radiation from the sun. All that deadly radiation from the sun was able to make it to the surface and killed a bunch of algae and plants. And then the algae and plants died, and a bunch of animals died too. It was a minor extinction event, and primarily in the ocean, if I remember right. I'm vaguely recalling these details. And we think it may be linked to a gamma ray burst because the reason we think that is that some of the gamma rays were able to penetrate down through the ocean and actually get into sediment and change some of the chemical composition of the mud and the rocks and stuff. And we've been able to measure that.
And someone said, how long ago was that?
I want to say, and I absolutely could be wrong about this. So
in the last 4.5 billion years, why don't you say that? In the last 4.5 billion years. I feel like you cover all your bases.
It was within the last 4.5 billion years. I think it was a minor event about 20 million years ago. If I remember.
They said, don't quote.
But don't quote me. Don't clip this video and say, Paul Sutter said extinction event from 20 million years ago definitely caused by gamma ray burst. Will it happen again? News at 5.
News at 5. How is astrology above physics but below biology? I don't know what we're talking about.
Because astronomy is in space. It's literally above us.
How much gamma rays would it need to get rid of our whole ozone layer?
I am not going to tell you that because I feel like you're going to misuse that information. That is dangerous. That is like figuring out how to build a nuclear bomb. Like we are going to keep it tight.
We're going to make a huge gamma ray gun. Oh man, it's so funny.
If hypothetically, if I were to generate a gamma ray gun on the moon, how much energy are we talking about?
If I were to go to the moon, hypothetically, in 2 years from now.
Yeah, I'm just saying, just as a thought experiment.
Was the entire planet affected or mainly the side hit by the gamma ray? So if it went over, if it hit the ozone, that would spread, wouldn't it?
It would spread, and gamma ray bursts last a few days.
Right.
They last a few days. So it'd be like a chicken on a spit. We'd get all sides cooked.
Yeah. I mean, it's obviously going to impact one side, but again, how things work. Wait, who can answer that anyway? But that's a great question, Anna. That's a really good question. And again,
how long do I have to keep this death ray running for? Is a couple hours enough, or do I need to get it for a few days? To make sure all the ozone is depleted.
Right.
Asking for a friend.
Right. Well, it's so funny because GRBs are one of the things, like I've heard, yeah, well, asteroids.
I'm going to insist on that. I'm going to insist on that every time.
Are we calling, what did you call them?
Gerbies.
That sounds like something that might be a sexually transmitted disease. I'm just going to say that's, I know. Okay. Well, it's fine.
Yeah, I got a bad case of Gerbies, a few years ago when I visited Bangkok. Never going back again.
Never going back. Don't feed it after midnight. Okay.
I mean, the rash was like this weird color. Even the doctor was surprised.
Yeah, and I'm not feeling really normal. I feel like my DNA might be mutated on certain levels. GRB, STD, whatever. I know, we can just use a bunch of OMG, right? There we go. Why does Sky always go to the dark side? That's me. So gamma rays cause nasty rashes confirmed. True. So these really aren't like a major threat to really us living on the planet today.
Not anymore.
Yeah. Did you guys hear that? So if you read something that's like GRB heading your way, you can chill out and be like, it's all right.
It's cool.
You're fine.
Because all the massive stars nearby our solar system that might have been a danger have already gone off. They lived a long time ago. Something like Betelgeuse, when it goes off, and I think I learned this from you actually, when it goes off, it will be brighter than the moon. And that will be really cool. It'll be visible during the day, but it won't be harmful.
Right. It's 643 light years away, according to Gaia. So,
Nothing.
It's close, relative, but it's
Close-ish,
not.
But also really far.
But also really far enough for if it were one of these kind of gamma ray bursts,
Gerbies.
Right, Gerbies.
Still not letting that go.
Never. If it's one of the Gerbies, then
because Gerbies don't let go of you.
It's the gift that keeps on giving. Why do you space people always say that? Say what? We didn't say anything. Did we say something?
What'd we say? Did we make a joke about space?
Space is deadly. You're all safe. Oh, well, it is deadly, but we are relatively safe. Relatively.
We're
supposed to.
On a scale from 1 to 10, one being literally in the core of the sun right now, and 10 being able to survive until the heat death of the universe, we're at a 6. A 6.
Great. Whatever, you don't leave the planet. But yeah, gamma ray bursts and space travel. That's going to be, not necessarily gamma ray bursts, but gamma radiation. Cosmic radiation.
Cosmic rays are the worst.
Yeah.
Let me tell you. Cosmic rays. Once you get above the Earth's atmosphere and out of our magnetic field, even here on the surface, cosmic rays are constantly pinging through you. And that's after all the protections from our atmosphere and our magnetic field. You get out there and it's just Cancer Town up there.
Yeah. It's no bueno.
All those cosmic rays, they just snip apart DNA.
Yep. Let's see. Can we detect Gerbies when they are not pointed directly at our system?
We, of course, don't know. We suspect some supernova explosions are GRBs that have not been aligned with us, but are still powerful enough that we can see it. But that's a maybe. It's a maybe. Yeah. And so light year's probably gone. Bang, already just waiting for the light to reach us. Oh, as far as Betelgeuse goes, potentially 643 light years. I think it has like a million years left estimate, which is in astronomy terms is like any day now.
Right.
It's going to blow. But for human time scales, it might take a while.
Yeah, I think people are honing in because, again, we have these supernova explosions about once per century in a galaxy. And we're kind of overdue. The last one we had was in
overdue. The last one that they happened, but not in the right spot. The last one that was visible in the day was in the 1500s.
Yeah, it was like 1604 or something, right?
Which is exactly in the 1500s. Yeah, you're right. I think it was 1600s.
Well, no, actually, I forgot about that one. My chat made me remember that one because I was going off of the Crab Nebula recently. And then I was like, oh, that's right. We did have one in the 1600s, like the early 1600s.
Right. Kepler took copious notes about it.
He did. And then we had one in the Large Magellanic Cloud in supernova 1987A.
That was a good year.
And that's all we've got. We're overdue. Why? Why are we not having any supernovas, Dr. Paul? Why is the Milky Way boring?
Why haven't I won the lottery yet?
Because your chances are like a 6.
What do you think I spent my advance on?
Any minute now. If Polaris goes, I give up on trying to learn. Well, Polaris will always be there, but as far as it being our North Star, that changes.
Yeah,
am I right?
You only have a few thousand more years to learn your star chart.
Just a few thousand. So better do it quick. Better do it quick.
But then you can wait. So if you miss it this round, you can wait another 25,000 years, and it will come back around.
Yeah. And someone said Vega. Yeah, it's going to be Vega. It's going to be our next
Vega and Thuban.
Thuban. Wasn't Thuban with the Egyptians?
The Egyptian North Star was Thuban.
So this all rotates, though, guys. I mean, like we go through the same ones.
Because the Earth is doing this.
Mm-hmm.
Not given one.
Yep. Not even caring. So, dear space, please send us supernovae ASAP. Thank you. We only need one. We just need one.
We don't want an invitation there. A little bit presumptuous.
Would gravitational lensing increase or diminish a Gerby's destructive power?
Yes.
Gravitational lensing would increase or decrease its strength?
My answer is yes, and I'm sticking to it.
Okay.
We can get Gerby's are already super tightly focused, right? The beam angle is like less than 20 degrees, so it's like this. It's already very highly collimated. And yes, if you were to put a very massive object, let's say a black hole, at the end of a Gerby, then as it's blasting out and it goes like this, then the gravity of the black hole would lens and amplify that light, kind of refocus it, acting like a lens, which would be like taking a magnifying glass on a bunch of ants.
Damn. Mr. Ryber says.
Is how you destroy the Earth.
Time to start designing a cosmic ray gun.
Yes.
Yes. And
oh no, I slipped.
You slipped. What did you do? So you're going to go after this. What are your plans?
Elon Musk is watching this right now and taking copious notes.
Absolutely. Absolutely. That is very cool. It is. I mean, and as much as we can learn about this stuff, again, these are both like, I decided to go with a very scary topic today because I knew a lot of my answers were going to be like, I don't know. We don't know. We are still learning. We don't know.
That's so fun.
But love it.
That's like half my book.
I know.
One of my favorite things, and I recount this story in the book of how I was researching writing the book. And I came across an article written in 1903 summarizing, it was titled like The Past 100 Years in Astronomy. And I read the whole thing. It was my favorite article, the favorite thing I read to research my own book. And basically the punchline was, we've learned so much, we have no idea what's going on.
Yeah. And you know, I
and
love
that was
it.
1903. And you could repeat that article every 100 years. From 1603 to 2003, going ahead to 2103. And the details might change, but that top line is exactly.
See, that's awesome. That's amazing. I like that. But when people are like, well, what do you know about these? You know, I chose kind of a tricky star. Huh?
We're working on it.
Yeah, there's a lot of other stars out there that we know theoretically exist. We do believe these to actually exist, but again, we just only have small numbers. We're not dealing with copious amounts of WR stars. So, but after this, so you're going to leave us, and then what is your day like today? Because we only have you for another 2 minutes.
The rest of my day, I'm probably I'm gonna do some cheese prep.
Right.
I'm not prepping the cheese myself. I'm going to eat some cheese.
Okay.
Because, you know, you got to plan that out. And before I get to the book launch party, which is the big cheese, if you will. No, my day has been pretty chill. I was on Weather Channel this morning. I had a couple meetings, a couple errands to run. I've been trying to keep it kind of low key. I've been practicing my talk that I'm giving tonight, but looking forward to the big party. And then a bunch of meetings tomorrow, and then hanging out for Thanksgiving and eating even more food, might or might not involve cheese. Mm-hmm. And then more events for me start next week. So a bunch of speaking gigs, a bunch of interviews, all that kind of stuff.
Yeah. So are you? That's what I was going to ask. To have already beat me to it, but like, are you going to broadcast anything from the book party?
We're thinking about it. I might live stream it on YouTube or Twitch or Facebook or one of those, depending on how many phones we can wrangle. But yeah, it might be fun to live stream that talk. But I want to see if like the lighting and sound looks good.
True. But you guys, he has a Twitter.
I don't want it to misrepresent my style or brand.
Right. But if you were going to live stream it or take pictures, the place to be able to find that would be your Twitter.
Twitter, yeah, just any of the social channels. Usually when I broadcast something or I post something, I put it out to Instagram, Twitter, and Facebook simultaneously. So just follow me on social media for all those updates. We'll be doing giveaways and all that good stuff too.
See, I have people in here saying they'd watch it grainy. They'd probably watch it at like 360p.
Watch it like quinoa.
Yeah, they'd be fine with it not being very resolved.
Super grainy.
Yeah. So,
okay, fair enough.
Yeah,
I would want to make sure the audio sounds good.
That's true. But can we get a bunch of Hail Sagans in the chat for him, guys? This is an amazing accomplishment. I'm super proud of you. And go enjoy your night. And I mean, we'll see you next Tuesday and then again Wednesday, unless we want to swap out Tuesday but I think either way, we'll see you. And that's very awesome. And go enjoy the rest of your evening and day. But mostly the evening.
Thank you so much. Again, I love coming on. I love doing these live streams. Excellent questions, by the way.
Oh, yeah.
About Wolf-Rayet stars. Very, very cool questions. Fun to answer. Tons of fun questions from the chat, as always.
Yep. All right. Well, we'll see you soon.
All right. Take it easy, everyone.
Take care.